We're working on Pierce logic, which is a logical proof system using existential graphs. E.g. is a graphical proof system. It's an alternative, at least to start with, for propositional calculus. Eventually, we'll also have alternatives for FOL and modal logic, if anybody knows what those are. There's 4 simple rules for doing propositional calculus for any sort of proofs, and there's only one operator, which is called the cut, and it's essentially equivalent to NAND, which, since this is theoretically comp-sci majors, people should know what that means.
FOL you can do in one line, right? First order logic. So that you can say one word, one sentence. You said FOL and modal, right?
Yeah.
First order logic, that's the first order logic with the existential and universal quantifier.
Okay. So anyway, first rule, double cut, it's reversible. So you can say that A is equivalent to A inside of 2 cuts, and A can be any premise or group of premise or a cut or multiple cuts or whatever. Second rule, iteration and deiteration. You can move a variable into, or copy a variable into a lower level, and you can also, if you have duplicates of the same thing on the same level, you can get rid of one of them, or you can add a duplicate of something on the same level. And if you have lots of layers, you can go as many layers down as you want. Third rule, deletion. You can only do this on even levels. So you can erase anything you want to off of an even level, counting for the base level is 0. And insertion on odd levels, nicely symmetric that. So here's an example proof for A or not A. We start off with the blank canvas, and then we double cut to get, well, a double cut. And then we move over to here, and we insert an A there. And iterate the A inside here. And double cut again. And then we've got A and not A, essentially. Because this is the structure of an A or not A, and this is the structure of an OR because it is not the case that not A and not A. It's kind of weird, but anyway, it works. Why we're doing this? It's a neat system for logical proofs.
Turn it over to Rob.
All right.
This part.
Okay, my part. Anyway, so I hope everyone got that. The inference rules. They're in actual logic. When you write it down, it works really nicely, and these rules are just 4, other than the ones you probably know from regular logic. So we're doing this for multiple reasons. First of all, it's neat. Has anybody ever heard of existential graphs before? A couple people. Yeah, Brahm's project. Brahm Van Gogh, that's right. Cool guy. And there's no software for this at all. Well, there's no good quality software. If you want to get like Java 1.1 applets that don't work in your browser, you can go ahead and do that. But when this no, go back. There we go. So when the system was initially made, no one could do proofs like this because it was the printing press era. So that's why you can see like for all and exists, they kind of just flip the symbols on the press. But like these types of proofs are graphical, right? So you have to draw circles and then put in stuff, and then you have to do frame by frame. You can't do that there. That's why we need software for it. We're in 2012, perfect time. And it's useful for educational reasons. And Professor Brahm actually said he'd use it in his class to teach kids existential graphs. And it's also a good way to get students in high school or middle school into logic and understand it without all the syntactic mumbo jumbo. So you're just drawing. Everybody loves it.
So also good. The Smullian's book on logic puzzles could be a good test candidate for this.
Yeah, we need to find a bunch of unit tests.
So that the Smullian's book on various gradations of. I have most of them. If you want to borrow, you can more than recommend.
Thanks.
Your transitions are so fancy, Sam. So how we're doing this, we initially used Qt, which is an awesome cross-platform C++ GUI framework, except that was too big of a gun to use for our project. So we scaled down, are using HTML5 and Raphael.js, and HTML5 is a cool guy, and Raphael.js is a SVG framework, and SVG is cross-compatible across mostly just all browsers, and super fast, because we're not making a game. This is static stuff that moves around time by time. That's much faster than using like an HTML5 canvas. And I'll put up a blog post about JavaScript libraries and HTML5 stuff over the weekend if people are more interested. And we also wanted to work on mobile devices, which this does, with some fun stuff added, but it's more work. And
It's not working on mobile devices yet.
not yet, yeah.
Yeah, multi-touch is down the road.
And it's just one metadata tag, but yeah. And we eventually want to make this so that, you know, a bunch of students can be sitting in a classroom and they can all be working on the same proof area, right? So you can just go to a website and then bam, you can see, oh, what's this guy working on here? And what's this guy working on here? And you can see all the whole proof, one big thing, and have like a proof repository that people can store proofs on.
So what do we have working right now? Right now we've got the basic data structures, mostly for cuts. So basically the structure of the way proofs work really lends itself well for a tree. If you think of each cut as like a node on a tree. So we basically have that implemented. You can also graphically display and interact with these cuts, move them around, do some cool stuff with that. That's really what Brothier is working on. Okay. We have the ability to store multiple frames of the proof, because when you think about it, every time we do an inference rule, we shift to a new picture or a new frame of the proof. So we can store a bunch of these, which together forms the actual proof. And we've started to get the inference rules in the back end. You can do some double cuts if we need to, and we're getting the template of the menu for the GUI. Do you want to do a demo?
Sure, demo. How do you use this demo machine?
Yeah. We've got one Mac user here, so.
All right. So this is the plane of truth.
Everything here is true.
Yeah.
But right now,
EG's work. So you can double click. There you go. Then you got a cut, and then you can double click again. More cuts, and then cuts inside of cuts, and then another cut.
we need some collision detection working. It's not
drag it around. Yeah, there's no. It's a rough alpha stage.
We don't even have variables yet. So
on the to-do list, but
yeah.
This is how the proofs are made. So you basically make a cut, maybe like insert a variable inside of it, and that's all.
We
you
don't
do.
have variable support yet.
Yeah, we.
Not yet. It's just text. And then you can make up your premises like you do in logic, and then do your inference rules, and then do your proof out.
Okay. So switch back.
Yeah.
That's cool. Nice. Okay. So now, what we plan to do for this semester, basically, get it working. We're starting this from scratch. So right now, as you see, we can start constructing things, but we don't actually have the capacity to even do a simple proof yet. We hope to do that by the end of the semester. This means we're going to need a usable GUI, something that users can interact with. We'll have to be able to input the premises so you can start the proof. All the inference rules have to be implemented. And using those inference rules, you should be able to build your propositional calculus proofs. So very simple stuff without the for alls and all that. Also, we hope to show like a few previous steps and have like a little bar at the bottom that shows like a little timeline of how your proof is changing. So you can go back and change things. If you say, oh, this is a bad idea, you can go back to an earlier state and proceed from there.
Like undo and redo.
Basically.
Which some software like Slate doesn't have.
Yeah. One of the real reasons we're doing this. But, you can save and load, hopefully, probably into an XML type format. And check if you proved your goal. Another good feature would be to, in the beginning, say what your goal is, and then have a little check mark once you reached it. course, we have a whole ton of future goals. Multi-touch is one of them that's not even listed here. Automated proof. Nope. Okay. Automated proof checking, so you know if you're on the right track. If you get to a point where you can no longer prove what you're trying to prove from the premises you have or the state of the proof you're at, you know you did something wrong. So that would be helpful. Another really cool thing we want to do is the ability to export the entire proof as like a video, because the proof is a sequence of different frames. That actual change that happens would actually look like a really cool video, and that would actually be the proof. Also, a cool thing would be bidirectional proofs. You know, sometimes you just start at your premises and just keep going, but sometimes you sort of start at your conclusion and want to go work backwards from there. So we want to be able to support that as well. And as you can see from that big example of A or not A, the normal person wouldn't really be able to tell that that was actually A or not A, because it's a cut with an A in it and then two cuts with an A in it. That's a little bit confusing. So if we hope to make a way to translate from normal notations into existential graphs. And as I said before, we hope to eventually support higher order logic like first order and more. So, any questions? Not that our computer's dead.
Questions?
Questions?
You said you had plans for video. Do you have any ideas on how you implement that?
Not really at the moment. I mean, what's basically going to happen is when we have this down, we'll have, and you do your proof, we're going to have every single frame of the proof stored. So maybe using some sort of delay, it should be basically a sequence of static frames, like a slideshow, is really what it's going to end up
I
being.
guess I'm asking about the actual generation of video. I would be impressed, but I'm not saying it's impossible to generate video from JavaScript or from a page.
Yeah, actually, it's actually Raphael doesn't exactly take care of that, but like doing the animations and stuff that makes videos look cool, it's easily doable in it, and just kind of working
That's
with that.
a future goal that's after we have all of this working, we're going to start thinking about then. It's a cool feature, but not a vital one. So we haven't really started thinking about it.
We have to fix subgraph isomorphism
So there
first.
is something called retrograde analysis. So you have a chessboard position, and the familiar question says, what was the first move, and who moved first, etc. That is again proposed. It's all well-studied problem, and there are software systems to do this retrograde analysis. It's comes into the bidirectional proof. That is, you are given the final goal, and if this chessboard position is this, question like who moved last. So,
I mean, that's not exactly what I was saying by bidirectional proofs. I mean, that would be a cool thing to be able to do.
Yeah, the thing is there are software systems that do analysis like this. It would be nice to include that in your system.
Maybe. I mean, this is mostly for a human who wants a concrete way of doing logic and using this sort of system to do it. It's not, well, we might want to have some sort of automatic proof checking and stuff. That's very much a sub-goal and not the primary purpose.
Also, fun fact, proofs in this system are on average much shorter than regular logic proofs. That's a plus.
And of course, for anybody who's used Slate, you know that Slate proofs are much longer than regular logic proofs.
Yeah. As you can see, proving A or not A, I remember trying to do that in Intro to Logic. It's not actually that easy to do in Slate. You have to do contrapositive, or you have to...
Weird stuff.
Yeah,
Anyway.
weird stuff. Anyway, any other questions? Okay.
All right, so
Thanks.